Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 KSP 6A. Today, we would like to present our tasks that were given to us on the topic hydrocarbon. So first, let me introduce my group members. Me, NABIHAH binti ZABIDI. My metric number is 9210343. One NABIHAH binti MAZLI 9210336, and lastly, NURUL AUFA ZAHIDAH binti ZULKARNAY 9210341. So let's proceed for the task A.
Okay, let's proceed with the question number 4. The information given here is on the addition reaction of bromine in CCl4 and in the dark reaction with 4 different hydrocarbon A, B, C, and D. So based on this information, we need to answer these 3 questions, which the first one is identify the hydrocarbon by drawing the structure. The second one is stating the IUPAC name, and the last one is write the chemical reaction for addition of A, C, and D. For hydrocarbon A, the structure is like this. Its IUPAC name is 3-methyl-pent-2-ene. The double bond here indicate it is an alkene group, and the parent's name here is pentene because the longest carbon chain here is only 5. The other carbon here is the alkyl group, and it is substituted to the carbon number 3. For chemical reaction, here is electrophilic addition. For hydrocarbon B, the structure is like this. Its IUPAC name is cyclohexene because cyclo is indicating in the structure is in the ring form, and while for hexene is because in this structure there is no double bond, therefore it is alkene group. So for chemical reaction, for this addition reaction is free radical substitution. For hydrocarbon C, the structure is like this, and based on this structure, its IUPAC name is hexa-1,5-diene because the double bond, these two double bond is attached at carbon number 1 and carbon number 5. Its chemical reaction here is electrophilic addition. For the last one is hydrocarbon D. The structure is like this, and the only difference between the structure of hydrocarbon D and the previous one, hydrocarbon B, is just only its double bond. Hydrocarbon D have double bond, which indicate it is an alkene group. Therefore, the IUPAC name is cyclohexene. The name for chemical reaction here is electrophilic addition. We're still in task A, but with different question. So the question here asked me to give the reason why hydrocarbon B do not form any addition product. So in this case, my hydrocarbon B is cyclohexene. It is an alkene and also saturated hydrocarbon, which it is because it only have one covalent bond. There is no double bond. So to initiate the reaction of cyclohexene with bromine, it must fulfill these two requirements, which the first one is a single bond must be broken, and the second one is it need the presence of energy in the form of light or heat. So in the previous information before, the hydrocarbon is react in the dark reaction, so therefore there is no reaction occurs for hydrocarbon B. Another question asked me to give the suitable reaction condition for the reaction of hydrocarbon with bromine. So in order for hydrocarbon B to react with bromine, it needs the presence of light and also the temperature greater than 100 degrees Celsius. With these two fulfillment of requirement, the hydrocarbon B, which is alkene group, can react with bromine through free radical substitution. Okay, let's proceed with another question. We're still in task A. First is draw the structure of the product. Second, state its IUPAC name. Also, the question asked me to state the type of reaction occurs and show its reaction mechanism. For product A, which have molecular formula C6H12Br2, the structure of product here is like this, and its IUPAC name is 2,3-dibromo-3-methylpentane. Its type of reaction is halogenation of alkenes in inert solvent. Now this is the reaction mechanism for product A. It consists of two steps, which the first one is the addition of electrophile and the second one is the formation of carbocation. This is the way how to write its reaction mechanism.
So this is the structure of the product. The IUPAC name is bicyclohexane and the type of the reaction is halogenation, free radical substitution. So what is free radical substitution? So this is a process where alkene react with halogen, which is in this case we use bromine, to produce haloalkanes in the presence of UV. Creation mechanism of this product consists of 3 steps, which is initiation, second one is propagation, and the third one is termination. So for the first step, which is initiation, UV is used to provide energy for this reaction to occur. So firstly, we write bromine Br2 as Br single bond Br. So one electron will be moved to the bromine and the second electron will be moved to another bromine to produce 2 bromine free radicals. The next step, which is propagation. So this step is the most important steps in this reaction because it will produce the major product. Okay, so bromine will react with the reactant, which is cyclohexane, to produce free radical cyclohexane plus hydrogen bromide. And then the free radical cyclohexane react with bromine to produce bromocyclohexane plus bromine free radical. And the last step, which is termination, is the step to stop the production of the radical. So both of the bromine radical will react to produce Br2. And then the cyclohexane free radical will react with the bromine free radical to produce bromocyclohexane. And the last one is cyclohexane free radical will react to the other cyclohexane free radical to produce bicyclohexane. This is the structure of the product, and the IUPAC name is 1256 tetrabromohexane, and the type of the reaction is halogenation of alkanes in inert solvent. Mechanism of this product. This process is known as halogenation because we are adding Br2 into the double bond in inert solvent, which is in this case we use carbon tetrachloride CaCl4 under dark condition. Reaction mechanism consists of 2 steps, which is addition of an electrophile, and the second step is formation of a product from a carbocation. So let's look at the first step, which is addition of an electrophile. So in this case, we have 2 double bond. So double bond is nucleophile, while bromine is electrophile. So the both of the double bond will attack to the bromine to form a carbocation plus 2 Br minus. And for the second step, we use the product from the first step, which is carbocation and 2 Br minus. So 2 Br minus, which has negative charge, will attack the carbocation that have positive charge to produce 1256 dibromohexane. This is the structure of the product. The IUPAC name is 1,2-dibromocyclohexane, and the type of the reaction is halogenation of alkenes in inert solvent. Of product D. So for the first step, addition of an electrophile, the double bond is nucleophile, while the bromine is electrophile. So therefore, double bond will attack the bromine to produce carbocation plus Br minus. For the second step, which is formation of a product from a carbocation, so we use the product from the first step. So Br minus that has negative charge will attack the carbocation that has positive charge to form our product, which is 1,2-dibromocyclohexane.
For task B, we were asked to choose one type of plant mentioned in Al-Quran that related to any functional group from chapter 5, Hydrocarbons. The verse that we found is verse 17 from Surah Al-Insan. Auzubillahi minasyaitonirrajim wa yusqawna fiha ka'san kana mizajuha zanjabila, means and they will be given a drink of pure wine flavored with ginger. So the plant that we choose are ginger. One of active compound in the ginger, which is the zingiberine, which is an alkene. So the organic structure, as you can see from this picture, and the IUPAC name of the zingiberine is 2-methyl-5,6-methyl-hep-5-ene cyclohexal-1,3-diene. The benefits of zingiberine is it is used in cosmetics and fragrances, and it also anti-fire, anti-ulcer, and anti-fertility effect. So the composition of plant, raw ginger contains 79% of water, 18% of carbohydrates, 2% of protein, and 1% of fat. In 100 grams, raw ginger supplies 80 kilocalories of food energy and contains moderate amounts of vitamins B6. Lastly, let us see a reaction involving zingiberine. So we found one of the reaction is called ozonolysis of alkene. This method are widely used to locating the double bond of an alkene. Like we can see here, zingiberine as an alkene will react with ozone O3 to produce an unstable compound called molozonides. The molozonides will rearrange spontaneously to form a compound called ozonides. So that will be the end of our presentation today. Thank you.